Good morning, students. Our today's topic in the subject of physics O levels is laws of magnetism and magnetic properties of matter. So this is very important topic. So concentrate yourself. We are going to start now. About 900 years ago, the Chinese first discovered that a certain type of the rock called magnetite or lodestone possessed a unique property. They found that a dish carrying a piece of the lodestone would float in water in such a way that lodestone always settled in a north-south direction. This unique property of the lodestone literally means leading stone, forms the basis for the compass, which is a very important piece of the equipment for navigation and exploration both on land and sea. So that was the beginning, that was the lead for inventing a device that is called navigation. A magnet has a north pole that is called N pole and a south pole that is called S pole. When a magnet is suspended freely like this, the north pole always point towards the northern end and the south pole towards the southern end of the earth. When a bar magnet is placed on a cork floating on water so that it can swing in horizontal plane like this, it comes to rest with its axis approximately in the north-south direction. The vertical plane in which the magnet lies is called magnetic meridian. So this is magnetic meridian, is a vertical plane containing the magnetic axis, and here are magnetic axis, that is north-south, of a freely suspended magnet at rest under the action of the Earth's magnetic field. When the ends of the two magnets are placed together like this, N pole with N pole and south pole with south pole will repel. Only N pole with S pole will attract. So the law of the magnetic poles is like poles repel, whereas unlike poles attract. Repulsion occurs only when both objects are magnets. At the two poles of the magnetic effects are strongest. So this is very important point to be noted. So at the two poles of the magnet, so here are two poles, north and south, the magnetic effects are the strongest. Experiment shows that the distance between the poles is approximately 5/6 of the length of the magnet. For example, the poles of the magnet 6 cm long are about 0.5 cm from each end. Magnetic materials like iron, cobalt, nickel and steel and alloy of iron and carbon are easily attracted by magnets, especially around the two poles. Non-magnetic material like brass, copper, wood and plastics are not attracted by the magnets. Here are some key points. A magnetic material is one which can be magnetized and is attracted to magnets. All strongly magnetic materials contain iron, nickel or cobalt. For example, steel is mainly iron. Strongly magnetic metals like this are called ferromagnetics. They are described as hard or soft depending on how well they keep their magnetism when magnetized. So magnetic material is called ferromagnetics. Now it will be further categorized into hard and soft metals depending upon the magnetism they keep. So now we are going to read one by one. Hard magnetic materials such as steel and alloys called alcomags and magnadur are difficult to magnetize but do not readily lose their magnetism. So these are the materials, hard magnetic materials, which are hard to magnetize but do not readily lose their magnetism. They are used for permanent magnets. Whereas the soft magnetic materials such as iron and metal are relatively easy to magnetize, but their magnetism is only temporary. They are used in the cores of the electromagnets and transformers because their magnetic effect can be switched on or off or reversed easily. So remember these definitions as well as their functions. So hard magnets are used for permanent magnets, whereas the soft magnets are used in the cores of the electromagnets and transformers. And the reason is because their magnetic effect can be switched on or off or reversed easily. Okay, the third definition that we are going to read is the non-magnetic materials. Include metals such as brass, copper, zinc, tin, and aluminium, as well as non-metals. Some such are paper and water. Can let the force of the magnetism pass through them. So these are called non-magnetic materials because they do not keep the magnetism. They let the force of the magnetism pass through them. Ferrous is Latin for iron. Magnet does not attract all metals. It only attracts cobalt, nickel, and ferrous metals. Ferrous metals are iron metals. The next thing that we are going to read is the properties of the magnets. So here are the properties and here is the description. So the first property that we are going to read of the magnets is attraction and repulsion. And here is the description. Like poles repel, unlike poles attract. However, any pole of the magnet can attract a magnetic material like iron, nickel, cobalt, and certain alloys of these metals by including magnetism on them. The next property is magnetic lines of the force. So here is the description. These can be traced out by using a small plotting compass. The closer the lines, the greater is the magnetic force. So this is very important point as far as your paper number 1 is concerned. The closer the lines of the magnet, the greater is the magnetic force. That magnet will be stronger. Magnetic forces is greatest at the poles. So this is another point to be noted. Magnetic forces is greatest at the poles. The direction of the magnetic line of the force is a direction that a north-seeking pole of a compass would point if the compass is placed in the magnetic field. The next thing that we are going to read is the magnetic field, and here is the description. This is the region in which the magnetic lines of the force exist. The number of the magnetic lines per unit area decreases drastically with distance from the magnet. So as you go far from the magnet, the number of the magnetic lines will be decreased. The next thing that we are going to read is the alignment. A magnet suspended freely will always align itself with the North Pole, pointing to the magnetic North Pole. This has always been a very useful fact for the seamen. So how they find their direction in the open sea? So this is a very useful property. The next thing that we are going to read in the lecture is induced magnetism. A permanent magnet can retain its magnetism for a long time. So this is again very important point to be remembered. It is also able to temporarily pass its magnetic effects to a magnetic material so that the latter gains the ability to attract other magnetic materials. Magnetic induction is the process of inducing magnetism in an unmagnetized ferromagnetic material. When a magnetic material is placed near to or in contact with the permanent magnet, temporary magnetism known as induced magnetism occurs. So this is induced magnetism. So whenever magnetic material is placed near to or in contact with a permanent magnet, temporarily magnetism known as induced magnetism occurs. In the following diagram, a soft iron bar is placed near a permanent magnet end to end. So here is a permanent magnet and here is a iron bar that is placed near the magnet end to end. So induced magnetism will be created in the iron bar also. There is an induced magnetism in the soft iron bar. The end near to the north pole of the permanent magnet becomes an induced S pole, while the other end becomes the induced N pole. So the end near to the north pole of the magnet will become S pole and the far end will become N pole. So these are very, very important points. Induced magnetism is not permanent. The soft iron bar will lose its magnetism once the permanent magnet is removed. So induced magnetism will be created, but once you remove the permanent magnet away from the iron bar, so the temporary magnetism will be finished. To check that the far end of the soft iron is an N pole, hang two iron nails near the far end of the induced magnet as shown in the figure. So look now, two iron nails are placed at the far end of the induced magnet. Here is the permanent magnet. The two iron nails become induced magnets and show a repulsion between the far ends. So they will repel. In figure above, if the far end of the induced magnet is an N pole, then the two iron nails which have also become induced magnets will have their far ends as N poles also. To check that, the far ends of the two iron nails are N poles, we bring an N pole of another bar magnet towards these two far ends of the two iron nails. A greater repulsion as shown in the figure below is observed, showing that the two far ends of the iron nails are N poles. So look now. So repulsion will be greater if we bring another permanent magnet closer to these two iron nails. The repulsion between the two iron nails increases. The next thing that we are going to read in the lecture is the key points. A magnet has a magnetic field around it, will attract magnetic materials by inducing magnetism in them. In some materials, for example steel, the magnetism is permanent. In others, for example iron, it is temporary. So these are very important points to remember. And a magnet will exert little or no force on non-magnetic materials. In a hospital, a strong magnet may be used to induce magnetism in a steel splinter and attract it from someone's eyes that is accidentally dropped. So this is the application of the induced magnetism. Induced magnetism is not permanent. The soft iron bar will lose its magnetism once the permanent magnet is removed. Magnetize a thin piece of steel, then break it in half and use a compass to test each piece. Each half is a magnet. So this is very important point to remember. So if we break the magnets, each piece will become a magnet. So this is very important point to remember. So this is the explanation. Magnetize a thin piece of the steel, then break it in half and use a compass to test each half is a magnet. Break each piece again, each piece will be a magnet. If we repeated this again and again, then we can imagine ending up with a very small atomic magnets. In an iron and steel, these atomic magnets line up with each other in groups called domains. So this is another point to be noted. In iron and steel, these atomic magnets line up with each other in groups called domains. Like this, they line up with each other. A magnet may be considered as being made up of numerous tiny magnets, all lined up with their end poles pointing in the same direction. Soft iron keepers are used in the storage of the permanent magnets to keep the alignment of the tiny magnets. So look now, soft iron keepers are used in storage of the permanent magnets. So this is very important point to remember to keep their alignment. Every magnet has a maximum possible strength. This happens when all the tiny magnets are aligned in the same direction. This is called magnetic saturation. So magnetic saturation is the maximum possible strength of a magnet. And this happens when all the tiny magnets are aligned in the same direction. Steel is called hard magnetic material because it is harder to magnetize and also does not lose its magnetism so easily. Steel is used to make permanent magnets. Permanent magnets are used in the compasses and as magnetic catches to keep cupboard doors shut, as in the refrigerator doors. Fridges and freezers have magnetic strips all around the door to keep the door completely closed and so keep the cold air inside. So here are magnetic strips. These are permanent magnets, and these are some kind of the nodes or decoration pieces that are attached with the doors of the fridge. Magnets are not only used to hold messages on the fridge doors, but a magnetic strip in the fridge door is used to hold it closed. A permanent magnet is placed in the oil sump tank of a car engine. So this is another very important use of the permanent magnet. A permanent magnet is placed in the oil sump tank of a car engine so that it collects any bits of the steel that are worn off the engine, like this. So it will not damage the whole engine then. So it will attract the tiny bits of the steel that are worn off. Iron oxide is another hard magnetic material. It is used to make computer discs, videotapes, and the recording tapes for tape recorders. The next thing that we are going to read in the lecture is magnetized and unmagnetized objects. In the following diagram, the tiny magnetic domains are shown by the arrows with the arrowheads as the end pole. In an unmagnetized piece of the iron, the magnetic domains are pointing in all directions and so cancel out each other. So this is very important point to be noticed. In the following diagrams, the tiny magnetic domains are all shown by the arrows with the arrowheads as the end pole. So these are magnetized objects, whereas in unmagnetized objects, the magnetic domains are all pointing in all directions and so cancel out each other. So this is unmagnetized iron. If the magnetic domains can be turned round to point the same way, then the piece of the iron becomes magnetized. So if they are aligned in the same direction, they will become magnetized. This is because all the tiny N poles added up at one end and all the S poles add up at the other end. So this is magnetized iron. Groups of the particular particles from which a magnetic material is made form tiny regions called domains. Each domain behaves like a tiny magnet. If the domains are arranged at random, the material does not attract other magnetic materials to it, although it can be attracted to a magnet. It also does not point north-south when it is free to move. So look now. Each piece is a magnet, so they are combined together to form a big magnet. So each piece is called a domain. The next thing that we are going to read is the magnetic properties of iron and steel. This is very important question which frequently come in the paper. Magnetic properties of iron and steel. So we are going to compare their properties. Number one, type of the magnetic material. Iron is soft, steel is hard. Magnetic property. Easy to magnetize and demagnetize iron, and that's why this is called soft magnet. And whereas steel is harder to magnetize and demagnetize, that's why this is called permanent magnet. Next, type of the magnet made. Iron is made as a electromagnet, whereas steel is called a permanent magnet. The uses of the iron magnet are transformers, audio and videotapes, electric bells, magnetic relays, reed switches and reed relays. Whereas these steel magnets are used in DC motors, AC generators, moving coil galvanometers, moving coil loudspeakers, magnetic door catches. Fridges and freezers have magnetic strips all around the door placed in oil sump tank of the cars so that it collects any bits of the steel that are worn off the engine. So this was the question. Next that we are going to read is to investigate the magnetic property of iron and steel. The apparatus used in this process will be bar magnet, iron and steel bars of the equal dimensions, 20 centimeter in length, iron paper clips. Procedure. So this is actually related to your paper number 4. So when iron is made a magnet with the help of the permanent magnet, it will attract a lot of the paper clips, but when permanent magnet will be keep away from the iron magnet, the magnetism will be finished and these paper clips will be dropped, almost all. So look now, let the end poles of the bar magnet attract one end of the iron bar. The other end of the iron bar is dipped into a tray of the paper clips. Record the maximum number of the paper clips that are attracted to the iron bar. So look here, a lot of the iron paper clips will be attracted. Put the magnet away from the iron bar. Observe that what happens to the paper clips. Record the number of the paper clips still attracted to the iron bar. Almost all the paper clips were dropped. So look now. A lot of the paper clips will be attracted when the permanent magnet was in contact with the iron. So when the permanent magnet was kept away, so almost all the paper clips were dropped from the iron bar. Whereas when the same process was repeated with the steel bar, so when permanent magnet was come in contact with the steel bar, less paper clips were attracted as compared to the iron bar with the steel bar. But when This permanent magnet was kept away from the steel bar. Some paper clips were dropped, but some paper clips were still attached with the steel bar because magnetism was kept by the steel bar. So look now, here is the explanation. Now repeat the same process with using the steel bar in place of the iron bar. Record the maximum number of the paper clips attracted to the steel bar. Pull the magnet away from the steel bar. Note and record the number of the paper clips still attracted to the steel bar. The next thing that we are going to read in the lecture is where magnetism comes from. So very important topic. So concentrate yourself. In an atom, tiny electrical particles called electrons move around a central nucleus. Each electron has a magnetic effect as it spins and orbits the nucleus. In many types of the atoms, the magnetic effects of the electrons cancel, but in some they do not. So each atom acts as a tiny magnet. In an unmagnetized material, the atomic magnets point in the random direction. So when the atom or material is unmagnetized, the atomic magnets will point in a random direction. But as the material becomes magnetized, more and more of its atomic magnets line up with each other. Together, billions of the tiny atomic magnets act as one big magnet. So this is from where magnetism comes from. Do you know that magnets can also attract or repel liquids and gases? Paramagnetic substances such as oxygen, nitric acid, and organic free radicals are affected by the powerful magnets. If you were to fill a soap bubble with oxygen and place it between the poles of very powerful electromagnets, the soap bubble would be stretched and flattened noticeably. You cannot do this with bar magnet. So electromagnets will be required for this process. Do you know that some farmers use magnets to separate the seeds of the cultivated plants from the seeds of the weeds? So this is very important everyday function of the magnets. So concentrate, this question frequently come in the paper. Farmers who grow crops such as flax, clover, and alfalfa use magnets for such purposes. These crops have smooth seeds, whereas weeds have hairy seeds. To separate these two kinds of the seeds, when a farmer sprinkles iron fillings into a mixture of the smooth and hairy seeds, the iron fillings will cling onto the hairy seeds of the weeds. So this is how the type of the seeds can be easily separated by using an electromagnet. The electromagnets would attract all seeds which have iron fillings stuck to them. Here are some key points. All magnets have the following properties. So this is a very famous question as far as your physics paper is concerned. The properties of the magnets. Number one, they attract magnetic materials such as iron. Number two, they have 2 points where the magnetic properties are concentrated, that is north and south pole. Number three, they always point in the same way when suspended freely. And number four, like poles repel, unlike poles attract. Repulsion is the only sure test of the polarity. So this is another point to be noted. When we will check either a material is a magnet or not, we will use the repulsion test. To test whether an object is a magnet, we can bring one end of this object towards one end of this suspended bar magnet. If repulsion occurs, then we can conclude that the object is a magnet, since repulsion occurs between like poles. If attraction occurs, then we can conclude that the end of the object is either of opposite polarity or the end of the suspended bar magnet, or that the object is simply a magnetic material. To test whether the object is a magnet, it would be necessary to repeat the test by bringing the other end of the object to the end of the suspended magnet to see whether the repulsion occurs. So remember, repulsion is the only show test of the polarity. So this was the lecture, students. I hope so this will be much interesting and easy for you to understand because I have worked a lot on this lecture. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.